So these are my top 10 calculator paper topics to watch before you sit the calculator paper. Things I just think are really likely to come up that appear most years and just really, common themes. So let's have a go at it. So first topic is compound interest. Now this comes up almost every single year. We're expecting it on the calculator paper just because we are going to have to put some of these numbers in our calculator. We're raising decimals to the power of something, so makes sense it's going to be on the calculator paper. So Northern Bank has two types of account. Both accounts pay compound interest. We've got the cash savings account, we've got the shares account. And the interest is 2.5% per annum in this account and 3.5% per annum in this account. Per annum means per year. Annum, annual, it's per year. Ali invests £2,000 in the cash savings account and Ben invests £1,600 in the shares account. Work out who will get the most interest by the end of 3 years. You must show all your working. Okay, so when we're doing compound interest, we need to do the amount of money multiplied by the decimal multiplier that adds on the interest. So if you want 100% of your money and you want an extra 2.5%, which is what we want in this case, looking at the cash savings account, which is what Ali's using. So Ali's using this one and Ben is using this one. So we're going to do 100% of our money because the bank's going to give you back 100% of your money, but they're going to give you an extra 2.5%. So 100% add 2.5%, that's 102.5%. Then the key with compound interest is to think, what would that be as a decimal? So if I wanted to keep a number the same, if I wanted 100% of a number, I would times by 1. If I wanted 110%, I would times by 1.1. 110% is the same as 1.1. So to get to the decimal multiplier, you're going to divide this value that you want by 100, and that's going to move all of the numbers 2 places to the right. So we're going to have 1.025. Now, each year that money is in the account, we're going to want to times it by 1.025. So if Ali is investing £2,000, we're going to times it by 1.025 for the first year. Then we're going to times it by 1.025 for the second year. And then we're going to take that amount and times it by 1.025 again. So ultimately, we're timesing it by 1.025 once, twice, 3 times because we want to know what will happen by the end of 3 years. But there's a quicker way of doing that. Because this is just multiplying by itself, we can just say that that is the same as multiplying by 1.025 cubed, and that is why the power is the number of years that you're getting that rate for. And that's going to take interest, add it on, and then take that new amount and add on the interest, and then take that new amount and add on the interest. That is what compound interest means. So typing that in my calculator, that is 2,153.78125. But since we're working with money, we want to round it to 2 decimal places. So we want to chop the number there, always check the next number. It's a 1, so it rounds down. So Ali is going to have £2,153 and 78 pence at the end of 3 years. Now, since she started with 2,000, the interest that she's receiving is actually the £153.78 part. Okay, now we need to look at Ben. So Ben is getting 3.5% in this account, but he's only putting £1,600 in. So we're going to do the same thing. £1,600 times. Now he wants 100% of his money each year and he wants an extra 3.5%. That is 103.5%, which is 1.035 as a decimal multiplier. Again, we're going to get that to 3 years, so to the power of 3. Typing that in my calculator, I get 1,773.9486, which is going to be £1,773.95. I'm going to take that 8 and round the 4 up to be a 5. So interest-wise, because he started with 1,600 and he's now on 1,773, if we subtract that, he's actually got an extra £173.95. Now, we're not going to get 4 marks at the minute. We have got both correct answers and we're happy with that, but they very clearly said to us, work out who will get the most interest by the end of 3 years. So we need to answer their question and we need to say that that would be Ben. So Ben gets more. In the third year, the rate of interest for the shares account is to be changed to 4% per annum. Does this affect who will get most interest by the end of 3 years? So the shares account was the account that Ben used. if his interest rate goes up, then he's going to get extra money in that third year. He's going to get more return on his investment. So actually, no, that's not going to affect our answer. It will just mean that Ben gets even more. No, it will not affect our answer, as it will just mean that Ben gets even more. So we're happy that that would still be the answer. If you've got a 1 marker at the bottom here, a part B, you don't tend to need to do any more maths. You just need to think about it logically. Which way would it go? What effect would it have? Okay. Next topic, probability trees. So this was question 15 on June 2018, paper 2. And again, really common topic. So a darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, the probability they will win on Sunday is 0.67. If they do not win on Saturday, the probability they will win on Sunday is 0.35. Complete the probability tree diagram. So always your branches, this branch, this branch, this branch, always need to add to make 1. So if we know the probability of winning on Saturday, Saturday is looking at this branch here, is 0.45, then your probability of not winning is going to be 0.55, because we know that either winning or not winning is going to need to add to make 1. We're certain that one of those two things is going to happen. Now it says if they win on Saturday, which means if we're coming up this branch, the probability they will win on Sunday is 0.67. So looking at the top here, I can put 0.67 for winning on Sunday, and not winning we know would need to be 1 subtract 0.67, which is going to be 0.33. Now, working with these decimals, it now makes sense why this is on the calculator paper. We're not going to be expected to do 0.45 times 0.33 or the associated sums in our head, so this is why it's probably on the calculator paper. It also then says if they do not win on Saturday, the probability they will win on Sunday is 0.35, so I'm going to pop that there. And if that's 0.35, again, we can take it away from 1 and find out the probability of not winning would be 0.65. So now we've filled out the probability tree. That's going to be 2 marks. For part B, it says find the probability that the team will win exactly one of the 2 matches. So in that case, we don't mind if they win on Saturday, but then we want them to not win on Sunday. Or the other situation where they would win only 1 match would be to not win on Saturday, but then win on Sunday. So those are the 2 situations that we want. We times along the branches, and then we add the ones we want. So we're going to do 0.45 times 0.33. And we're going to do 0.55 times 0.35. And then we're going to add those 2 answers together. So typing those in my calculator, that is 0.1485 and 0.1925. Adding those answers together, we get 0.341. So that would be our answer. That is the probability of the team winning exactly one of the 2 matches. Be careful of questions that say at least 1. That means you need to include the opportunity of them winning both matches, but that happens every now and again. That was a 5-mark question, so well done if you got that. Question number 8, next topic is transformation. So this was taken from November 2018, again paper 2, and we need to reflect. So triangle P is reflected in the line y equals minus x. Now the line y equals x looks like this, going this way through the origin, through the point 1, 1, 2, 2, 3, 3, 4, 4. The line y equals minus x is going the other way. So it's got a negative gradient, which we would expect. That is the line y equals minus x. And we need to reflect in that line first. So when you are doing a diagonal reflection, you need to count diagonal squares. We're always counting perpendicular at right angles to the mirror line. So that point there is 1 diagonal square away. So it's going to remain 1 diagonal square away on this side and go there. This corner is 1, 2, 3 diagonal squares away, and it's going to stay 3 diagonal squares away and go to here. And this point here is 1, 2, 3, 4. So 1, 2, 3, 4 diagonal squares on this side, so it's going to go there. And then all we need to do is join those up. So I'm going to go here, I'm going to go here, and I'm going to go here. And we know that that is triangle Q. Getting rid of those lines. So we've done that and we're going to label it Q. It then says triangle Q is reflected in the line x equals -1 to give triangle R. Okay, so x equals -1 is going to go through -1 on the x-axis. A little bit confusing, sometimes students get confused because it's going in the same direction as the y-axis, but it's x equals. Reason for that is because every single coordinate on that line has an x coordinate of -1. They're all -1, 2, -1, 3, -1, -3, whatever, but the x coordinate is always -1, and that's why we call that the line x equals -1, so it goes through -1 on the x-axis. And again, we're going to reflect it, so it's going to be 2 squares away, and it's going to stay 2 squares away, so it's going to go here. Hopefully that one's a little bit easier to see. There we go, and that's going to be triangle R. It then says, describe fully the single transformation that maps R to P. So be very careful, R to P, not P to R. So we're trying to go from R to P. And hopefully you can see that that has rotated. So you've got 4 transformations: reflection, enlargement, rotation, and translation. If you are asked to describe fully the single transformation, you are allowed to pick one of those words and one only. As soon as you write more than one, you will lose all marks. So pick one carefully. Here we can see that that has been rotated. Now, to see where it's been rotated from, I would recommend putting your tracing paper over the top and then drawing R on your tracing paper and then just spinning it until it lands on Q. And then just try different turning points. It's going to be here. So this is the point where we're going to be turning it around. If you drew over your triangle here and you popped your tracing paper over the top and you spun it, it's going to land on P. So we would say that this is a rotation. 90 degrees. Now we're going against the direction of a clock because we're going this way. So that is anti-clockwise. Around the point. Oh, I'm not going to put the point because I'm running out of room, but around, and it is -1, 1, that is your point there. So that's rotating around that point. We've got to say the direction, we've got to say that it's a rotation, we've got to give the point, and we've got to say 90 degrees. And we can tell it's 90 degrees because this triangle was pointing up here, and now it's pointing left. So that is a 90-degree turn. Next topic, Pythagoras. So question number 5, here is a right angled triangle. The shaded shape below is made from 2 of these triangles. Work out the perimeter of the shaded shape. Give your answer correct to 3 significant figures. So I know that I need the distance around the outside. I need this bit, and I also need this little bit here. I need the 10 here, the 8 here, and the 8 here. So the distance all around the outside of the shape. Now I know that this is 8, and I know that this is 8, and I know that this is 10, but I don't know this. But this is the hypotenuse of the triangle. If you know 2 sides of a right angled triangle and you want to know the 3rd side, we're going to need to use Pythagoras. So in this case, we're going to do 8 squared, add 10 squared, which is 64, add 100, which is 164, and then we're going to square root that answer, which is 12.806. But for the minute, I'm going to just leave it as root 164. It keeps my answer accurate, and I'm going to pop that there. So I know that this bit is root 164, or 12.8 if you'd rather. Now, to find out what this little bit here is, it's going to be the difference between this length, which we know is 10, and this length, which we know is 12.806 or root 164. So in my calculator, I'm going to type root 164, or I can use the answer since it's still sat in my calculator, take away 10. And that's going to get me an exact answer for that little bit there. And of course, it's going to be 2.806 and the rest of it. I'm then just going to add all of that together. So the perimeter is the distance all the way around the outside. So we need to do 10, add 8, add 8, add that answer, add that answer. So let's put that all together. 10, add 8, add root 164, add, this bit also has a third form, but I'm just going to put 2.806. And then I'm going to keep this as the answer in my calculator. So then all I'm doing is keeping that answer, adding 10, adding 8, adding 8, and then adding root 164. And I've not rounded anything that way. I've kept it all super accurate. Press the SD button if you need to, and that's going to be 41.612. 3 significant figures, so that's your first significant figure, that's your second, and the 6 is the third significant figure. Check the next number, it's a 1, so it rounds down, so 41.6 is going to be your answer for that one. Question number 12, and we're doing SOHCAHTOA. So for SOHCAHTOA, you might find it helpful to do those three triangles, write them out. So we've got to work out the size of angle EAD. So this is what we're being asked to work out. I'm just going to pop a little X there so that we know what we're working out. Now, first thing we're going to start with is actually this triangle on the right. So the triangle BDC. The reason I'm starting over here is because I do not have enough information in this triangle to do anything. The only thing I know is 4.4. That's all I know, and that isn't going to be enough. You're going to need at least two things to be able to do SOHCAHTOA or to be able to do Pythagoras, and I don't have two things, I only have one. But I do have two things in this triangle. So I'm going to start by labelling. 8.6 is my hypotenuse. And then I'm going to imagine I'm stood in this angle looking into the triangle. So BD, this side here, is my opposite. And down here between the right angle and the angle we're interested in, that is your adjacent. Now here it's going to be helpful if we can work out what the opposite is. If I know what this opposite is, I know that E is the midpoint from the question. They've told me that E is the midpoint of DB. So then I can half that answer and get some more information about that triangle that we're interested in. The adjacent, I don't really know it and I don't care what it is. It's not going to help me on this question. We've got the hypotenuse, we want the opposite. So O and H is what we're going to use here. And that's going to be SO. So O and H, we're using the SO triangle. If you want the opposite, cover that up and do the sum that's left behind. And that's going to be sine 40 multiplied by 8.6. Remember, this is sine of the angle, this is cos of the angle, and this is tan of the angle, depending on which triangle you're using. So sine 40, don't forget to shut that bracket after the angle, multiplied by 8.6, and that is going to be 5.52793. Don't round anything until you get to the very, very end, otherwise you're going to lose accuracy in your answer. I'm keeping that in my calculator, and I'm going to divide it by 2, because that's then going to get me this length here from E to D. So dividing that answer by 2, answer divided by 2 is 2.76398. Keeping that many decimal places should be absolutely fine. I'm then just going to redraw this triangle here. So let me just change colours. Let's make it green. I'm going to take this triangle and I'm going to redraw it just down below here so you can see it a little bit clearer. So the green triangle there, let's redraw it. And we know that it is 4.4. We want the angle. And we now know that this side here is 2.76398. Labelling this side, I know that this is the hypotenuse. This side is my opposite, because it's opposite that angle that we're interested in. Again, if you're looking across the shape from that angle, that's where it's opposite. And here we've got the adjacent. So with this triangle, we've got the opposite, we've got the adjacent, and so we're going to use TOA to work that out. TOA is the triangle involving the opposite and the adjacent. So because I want the angle, I'm covering up the T, and we know we need to do tan to the -1 when we want an angle. So that's going to be tan to the -1. O is on the top and A is on the bottom. So opposite on the top, which is our answer, 2.76398, and the adjacent on the bottom, which is 4.4. There we go. So typing that in my calculator, and I'm just going to press Shift Tan, and I'm going to keep that answer on the top. So I'm going to press the fraction button and then just use answer. It was still in my calculator, so I might as well use it and keep it super accurate. And that's going to be 32.136, 1 decimal place, so 32.1 degrees. Question number 16, and we're doing parallel and perpendicular lines. So the most important thing to remember about parallel lines is that they will have the same gradient. Two lines that are parallel on a graph must have exactly the same steepness, so they're going to have the same gradient. If two lines are perpendicular, so they're at right angles to each other, it will be the negative reciprocal. So if this one has a gradient of 2, then this one will have a gradient of negative 1/2, because that's the reciprocal. If this one had a gradient of, let's say it was 2/3, then this one would have a gradient of negative 3/2. So you're making it negative and you're doing the reciprocal. If it was negative, you'd then make it positive, and so on. So let's get rid of that and have a look at this question. The straight line L has the equation 3y equals 4x add 7. The point A has coordinates 3 minus 5. Find an equation for the straight line that's perpendicular to L and passes through A. Okay, so we're going to take that line 3y equals 4x add 7. Now I would like to know what its gradient is, because in order to do a line that's parallel or a line that's perpendicular, we need to know what the gradient is. And the gradient is normally the number in front of the x, but only when it's in the form y equals mx plus c. So in order to look at this number and see that it's the gradient, that y needs to be the subject of the formula. And here we don't have that. We've got 3 lots of y. So I'm going to divide both sides by 3 to begin with. Now, normally you just say put it all over 3 like that, right? But we're not going to do that here, because if we do, we're not going to get our individual elements that we're interested in. So I'm going to divide each bit by 3. So this is 4 divided by 3, x, add 7 over 3. So I've still divided it all by 3, but just each bit in turn. And I can now see that the gradient is 4/3. Now, if we were doing a line parallel to that, I would say, okay, y equals 4/3 x add c. But we're not going parallel, we're doing perpendicular. So I need to do the negative reciprocal. So we're going to write y equals minus 3/4 x add c. And this is the negative reciprocal of this gradient. Now, I need to know a point that lies on the line in order to work out what c is. If a coordinate, like they've given us this one, lies on the line, it will make the equation true. And with 3 minus 5, we have an x coordinate of 3 and a y coordinate of minus 5. So I'm going to put minus 5 where the y is, equals minus 3/4 times 3, add c. So you're just putting the x as 3 and the y as minus 5. And c just has to take whatever value is going to make this equation true. So I'm now just going to pop in my calculator, minus 3/4 multiplied by 3, which is going to be minus 9/4. So minus 5 equals minus 9/4, add c. Remember, when you actually multiply a fraction, you just multiply the top. If you multiply the top and the bottom, you'll just get an equivalent fraction. And I'm now going to add 9/4 to both sides. And that should tell me what c is. So minus 5, add 9/4. Remember, it's a minus, so to get rid of it, you're adding it to both sides. And that is minus 11/4. So c needs to be minus 11/4. So y equals minus 3/4 x minus 11/4 is the equation of the line. Now, sometimes they say, can you get that in the form ax add by equals c? And all that means is, can you get the x and the y on the left-hand side of the equation and the c, the constant term, on its own? And we don't want any fractions. Sometimes they'll say as integers, whole numbers. Common on the very, very end of the paper. So let's have a look at how we might do that. You didn't have to do that for this question, but it's good knowledge to have. So let's start with y equals minus 3/4 x minus 11 over 4. Now, these fractions are a little bit annoying. They're both 4. So let's multiply both sides of the equation by 4. And then we get 4y equals minus 3x minus 11. And then we would add 3x to both sides. So 4y add 3x equals minus 11, and now it's in the format that they've asked us for it. So that's just a little bit extra. You don't need to know that necessarily for those questions, but it's helpful if they do ask you to get it in that format. Okay, question number 12. OAB is a sector of a circle with centre O and radius 7. So we're looking here at areas and arc lengths of sectors. Might be circles, might be sectors, not sure, but it's good to have this knowledge and think about those formula. The area of the sector is 40. So whenever in maths they are giving you the answer to something, I would like you to write down, here is how I would work that out, and fill in everything that you know. So the area of a sector is pi r squared times theta, or x, over 360, where theta is this angle here. You can put x if you like. And we know that that equals 40. So we're doing the area of the whole circle, and we're timesing it by the fraction of the circle that we've actually got. So if we knew it was 50 degrees, we'd put 50 out of 360. If we knew it was 100 degrees, we'd put 100 out of 360. But that is the bit here that we do not know. So we're going to say pi times, now the radius is 7, because the radius goes from the middle of the circle to the edge. So pi times 7 squared times theta out of 360 equals 40. Now I can actually do this bit, it's 49 pi. So then I can divide both sides of the equation by 49 pi. So theta over 360 equals 40 divided by 49 pi. And that is 0.2598. How am I then going to work out that angle? Well, it's being divided by 360 at the minute. We want to undo that, so we're going to times both sides by 360. Again, I'm not taking that answer out of my calculator, I'm just going to times it by 360, and that gives us 93.544. So the missing angle, we now know, is 93.544. Great. I can now fill that in. They want the perimeter of the sector. Now, if they just ask you for the arc length, then they're just asking you for this part. If they ask you for the perimeter, you're going to need to take that arc length, add on 7, because we know that perimeter is a distance all the way around the shape. Now, how would we get that arc length firstly? It's going to be in the same way that we wrote this, but instead of pi r squared, which gives us area, we're going to use pi d or 2 pi r, depending how you learn it, so that gets us the circumference of the circle. So pi d times, now we don't need to use theta anymore, we can use 93.544 out of 360. I'm going to not round it, I'm going to use the answer in my calculator again, and we want to know what that equals. The diameter would be all the way across the circle. Imagine you had the whole circle there, it's going to be 14 all the way across because it's double 7. So pi times 14 times this fraction, so I'm going to use 93.544 as I write it down, but in my calculator I'm going to put answer there because I've got the 93.544 still in it. So pi times 14 times answer over 360, and that is 11.428571. That's the arc length. But we're not quite there. We also need the perimeter. So we're going to need to add on the 7 and the 7. This bit is your 11.428571, but the perimeter is that add the 7, add the 7. So again, I'm not taking it out of my calculator. I'm going to do that answer, add 7, add 7. We can just add 14, and that gives us 25.428571, correct to 3 significant figures, so that's going to be 25.4. The next numbers are 2, so 25.428571, they're recurring, but that just means it goes 428571, 428571, and keeps repeating like that. For 3 significant figures, we're going to check that 2, first, second, third. The 2 rounds down, so 25.4. Okay, next topic is circle theorems. Become really familiar with them all, it's just a good idea to know them. There are some that get asked a lot, angle at the centre, angles in cyclic quadrilateral, things like that, and both of those were on this question, which is why I picked this one. So A, B, C, D are points on the circumference of a circle, centre O. A, D, E and B, C, E are straight lines. Work out the size of angle C, D, E. So always what they're asking you, you're going to put an angle there and you're going to say that's angle X, so we know what it is that we're working out. Okay, and then I would just fill in what you know. Okay, don't try and judge and see what we're going to do in the long game. Just let's have a go and see what we know. So we know that when we get that arrowhead shape, that the angle at the centre is double the angle at the circumference. So I'm looking here at this shape, and I'm saying that angle 132 is double this angle here. So 132 divided by 2 is 66. So I'm saying that angle there is 66 degrees. Now, if we've got that one, we can then have a look at this one, because opposite angles in a cyclic quadrilateral, which is when all 4 corners are touching the edge, let's have a look at that. So if I do it in red, a cyclic quadrilateral has to have all 4 corners of the quadrilateral touching the edge of the circle, and the opposite angles will always add up to make 180. So opposite angles adding to 180, take away 66, that is going to be 114. So there we go, we've now got that one. Now I then know that this angle here, because we're on a straight line, will add up to 180, and we know that that's going to be 66 from the calculation that we just did. And now we've got a triangle. So that triangle, the angles in that triangle, let's do a different colour, yellow, let's add to the mess of colours that we've got here. That triangle there, the angles in that need to add up to make 180. So I can do 66, add 16, which is 82, take that away from 180, so 180 take away 82 is 98 degrees. So X is 98. That's the maths, but because it says give a reason for each stage of your working, we are going to need to write that down. So first thing we did, we said angle BAD equals 66 degrees, angle at centre is double angle at circumference. The second thing we did is we said that angle BCD is 114 degrees, opposite angles in a cyclic quadrilateral. Add to 180. And then the third thing we said was angle DCE equals 66 degrees, angles on a straight line, add to 180. And then we said angle CDE, which is what they asked us for, is 98 degrees, angles in a triangle, add to 180. There we go. So that would get us full marks now, and the answer on the answer line needs to be 98 degrees. 4 marks for that. Probably 2 for the maths, probably 2 for the reasons. So make sure if it says give a reason for each stage you're working that you are writing those reasons down. Okay, next topic is types of graphs. So really common now, matching up the graphs. So we're just going to go through each of these. We actually only need to identify 2 of them, but it's a good idea to know a little bit about each of these graphs. So this first one, A, this is a quadratic graph. It's going down, it's coming back up. With a quadratic graph, it might be this way up, it might be that way up, but it's going to have that x squared as the highest power. If it's positive, it'll be positive x squared, and if it's a sad face, that negative parabola, it's going to be minus x squared. But that's a quadratic graph. For this one, we've got a cubic. Now, this is going to be something like y equals x cubed add 5x or something. It's going to have another term. If it's just x cubed, it looks like this one, where it's going through the origin, but you're just turning at the origin and going back up. You don't get that full wiggle that you're getting with the other one. And you're not going to have another number. Now, if you had something like +2 on the end, we know it would go through at 2. So this is going through at the origin, so we know that that's not going to have anything there. Something like that. For these two, C and D, they are reciprocal graphs. So we've got this one would be something like y equals 1 over x or 2 over x or 3 over x. This one is the positive version, and the negative version here is going to be something like y equals minus 1 over x. Might be minus 2 over x or 3 over x, whatever. But if it's positive, it's going to be in this quadrant and this quadrant. And if it's negative, it's going to be like this one in the other 2 quadrants. The way I remember the reciprocal graph is that I think the graph itself looks a bit like a fraction. It's got a top bit and a bottom bit. So there we go. Those are reciprocal graphs. Then for E, it's a straight line. So we're expecting... For E, it's a straight line, so we're expecting something in the form y equals mx plus c. We can see here that the gradient is positive, so it's going up. So maybe it's y equals, I don't know, 2x, or it could be a half x or whatever. Let's just guess a half x because that's positive. It looks quite shallow. We've got no idea because we can't tell the units, but we do know it's positive. And it's also going through at a positive value, so maybe +5 on the end there as well. So we've got a straight line there, and then that last one is just x cubed, something like that. Might be 2x cubed, but x cubed. So then looking at that, hopefully that makes sense. If I say that that first one, x cubed, that is f, and for that second one, b, 1 over x, we're going to join that up with d. That is your positive reciprocal graph. There we go. If you're not sure on those, use something like GeoGebra or Desmos. They are free online platforms where you can just type stuff in and see what it looks like, and that might help you to familiarise yourself with the graphs. But I always think, what would happen if x is 1? What would happen if x is 2? What would happen if x is 3? And then think about those values as you're going along, what would happen to y as well. Okay, question number 17. This is the last topic that I've done in this pack, and this is going to be histograms. I've chosen one where you have to do it completely from scratch, and then we can have a talk about it as we go through. So on the grid, draw the histogram. Now, the most common mistake I see when I'm marking these papers is that people take the frequency and put it up the y-axis here. This is never going to be the case, okay? You do not put the frequency on the y-axis. You put something called frequency density. Now, frequency density, I'm just going to put FD up here, is the frequency divided by how wide this category is. So I always remember it by thinking it's frequency divided. And you're going to divide it by how wide the category is. That's called the class width. In this case, to get from 140 to 150, that is 10. So we're going to do 15 divided by 10, and that is 1.5. 30 is going to be 30 is going to be divided by 5, and that is 6. 51 is going to be divided by 5, and that is 10.2. 36 is going to be divided by 5, and that is 7.2. And 18 is going to be divided by 15, and that is 1.2. So then these are the values that we're plotting up the side. So we can see that we need to make sure we're going up as high as 10.2 to be able to plot that. And looking at my graph, I think it makes sense to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. So they've given us enough room to do that, which is perfect, and go up in one square. Don't go up in odd things. You don't really want to be going up in 0.3s or anything like that. It's, yeah, keep it as simple as you can. Go up in 1s or go up in 2s or go up in 10s, something nice and straightforward, or 5s if you have to. There we go. So I'm plotting those values. Now along the x-axis here, we're going to need to put 140 up to 180. So let's go 140 here, 150, 160, 170, 180. Yeah, perfect. So let's go 150. It's always nice when 10 squares is 10 units as well, isn't it? 180. There we go. We don't need to go any higher than that. So then we're going to draw the bar as wide as the class interval. 140 to 150 goes up to 1.5. So 140 to 150, and we're going to draw a bar that is like that. The most important thing you need to know about histograms is that the area of each bar is the frequency. So if you worked out the area of this rectangle by doing base times height, that is 10 times 1.5, which is 15. So there are 15 people represented by that bar, and that's correct because we can see that that's what it was in the table. The next bar has a width of 5 and a height of 6, so let's draw that. It's only 150 to 155, that's why it's narrower. And then we've got 155 to 160 going up to 10.2, which is going to be one little square above. Each square is 0.2 in our y-axis direction. Then I've got 160 to 165 is at 7.2, like that. And for the last category, we're 15 wide and we're going up to 1.2. So that is going to be here, up to 180. That's our histogram correct, so we get 3 marks for that. Then it says work out an estimate for the fraction of the students who have a height between 150 and 170. So to do that, we need to think how many students are represented by this area. Oh, I could do with deleting that bit now, couldn't I? Oh no, I've rubbed out my thing. 1 there you go. How many students are in this bit, this bit, this bit, and this bit? So the students that are between 150 and 170 are the area represented by those bits that I've cuddled. Oh, I can't talk. It's the area represented by those bits that I've coloured in. So in each case, we could just work out the area of the rectangle. For the full bars, we can just use the data that's in the table. So we know that this one is going to be 30 children. Add this second bar is 51 children. The third bar is 36 children. For that fourth little bit, we need to work out the area of that bar, and that is done by doing base times height. So it's 5 wide here, and it's 1.2 tall. So 5 times 1.2 is going to be 6. So that's 6 students that we expect to be in that bar. We don't know for sure. They might all be grouped up in this top end of the category, but we're going to spread them equally between the bar and just assume that they are spread equally. So we've then got to add all those values together. So 30, add 51, add 36, add another 6 is 123, but they want this as a fraction out of how many children there are altogether. Now you could add together all of the area of all of the bars to get the total number. You could also add together all of these in the frequency column, or you can read the question and notice that there are 150 students. So even quicker, that would be our answer for that. Let me know if you've got any other topics that you'd like me to do ahead of the calculator paper. I hope you found that helpful. Let me know in the comments if you've got any questions.